Are you ready?
I'm ready.
Okay. So 9A was determine the null and alternative hypotheses. And then it was just H little
For
thingy
number one.
for 9A.
Oh, sorry. I'm on. Okay. Yeah, I'm
Oh,
like,
you're fine.
I was looking at problem one, part one. I'm like, oh, okay. Yeah, determine the null and alternative hypothesis was the HO of the mean is equal to 529, and the HA is the mean is greater than 529. So got that. 9B, suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean score of the students taking the exam is still 529. What is a type 1 or type 2 error committed?
Type 1.
Yeah, and I know I just need to memorize those.
Mm-hmm.
I can find the answers on the page, but I need to just commit those to memory. And that's what a lot of the stuff he said was just memorizing it and understanding that's just part of the definition. So.
Mm-hmm. Okay. See if the analysis was done at A equals 0.01 level. What is the probability of committing a type 1 error? I basically just moved the decimal point over and got 1%.
Yeah, I actually read the answer because I wasn't quite sure. And when it says there's about a 1 in 100 chance or a 1% chance that there would be a type 1 error, it makes sense. I'm like, okay, that's basically changing the decimal to a percentage.
Yeah, because like the probability is usually like, I know that when we put it into the applet, it's usually like we move it from like, if it was 20%, then we would do 0.20.
Mm-hmm.
And so I kind of just related it to that.
And then D, if we wanted to decrease the probability of making a type 2 error, we would need to increase or decrease the level of significance. And that's increase because basically type 1 and type 2 are opposite ends. So if you're decreasing one, you're increasing the other.
Mm-hmm. All right.
And number 10, I just used SPSS. Did you do that as well?
I tried to do SPSS. So I did SPSS for most of it, but then I got stuck somewhere. Maybe I didn't. Maybe I figured it out. I think I figured it out. I got stuck because it kept telling me that my numbers were string, and I had no idea what that meant. So, oh, I got stuck doing the scatter plot. I couldn't figure out how to make a scatter plot with my variables, but that's
Was
a
that the
couple.
QQ plot?
Things.
Or
So it was D number 1.
D number 1? Yeah, that was a QQ plot
Oh, QQ plot?
is what it was called. Yeah, so basically if you go into the analyze data
Yeah.
and you do the, let me go back to it and see, it's the analyze data. Sorry, let me go into the other one. Okay.
Because
And you
on
do
the,
the,
I looked at the answer, and it looked like a scatter dot.
yeah, I
Plot.
actually went and I watched the video
Okay.
that it was a QQ plot. So basically analyze descriptive statistics and go to a graph that has the bar that's going up and shows you the points off of it to try and see if it's normal or not.
Okay.
You want to try and do the QQ plot on that? Do you still have it open?
Yeah, I just have to grab the numbers.
Yeah. Telling you whether it's normally distributed or not.
And did you just do them in the like a row down?
Yeah, I just basically made one row and I just did the numbers. And then when I typed them in, it initially put like a .00. I had to go
Uh-huh.
into the variable view down at the bottom, not the data view, but the variable view, and kind of
Yeah.
define that I wanted it to be 0 decimal points.
Okay. So,
The variable view is also where you can like give the name to the variable, I think. Like if you wanted to say years old or something.
okay, I see it now. Okay. Neat. Thanks for that help. So I was trying to do it the other way, the wrong way. So of course it doesn't work. Okay.
It's a lot to try and figure out, but yeah, I'm trying to
Good
make sure
luck
I
with
understand
mine.
it. So yeah, I went through the video just before I got on this just because I wanted to make sure I was doing it right. Because I'm like, I don't know, does that mean when it says check the requirements, since there's only 15 pieces of data, because if you have n equals 15, if it's right skewed or left skewed, then it's not normal, right? So you kind of need to know that it's normal to be able to do the computation. So I'm like, hey, if the data is normally distributed, I'm like, well, I better make sure I understand what they're talking about. But then when he showed the QQ plot, basically that does show it's normal because it does the line and it has it mostly following it.
Yep. Right. Glad I know that
Okay,
now.
so D2. Oh wait, did you want to go? I guess we kind of skipped through the other ones.
Well, we can go to B. That one's,
NB.
yeah.
Okay. Yeah,
Yeah.
10B. He said that there's lots of different ways that you can do it. I was thinking when I answered it before I watched the video, I'm like, well, maybe stratified so that you could have a group of people who brought the properties and then choose. But it was specifically talking about how he chose more than just stratified. He's like, well, you can do Excel and do a random number generator, or you can put them in a hat and have someone pick them out.
I did convenience because they were his clients. And so I was like, that's pretty
Yeah.
convenient. Like, he doesn't have to go look for these people because he already's worked with them and stuff.
Yeah, I wasn't sure. I was on the same thing though, like trying to figure out whether it was stratified or cluster or what method would be the best way to do it. But no, they just wanted to say, hey, how is he going to select it? He could have used a random generator in Excel or put them in a hat and pulled certain numbers out or whatever. But I'm glad I watched it because I'm like, I'm trying to answer this. I think I know what I'm thinking, but
And then you guys,
yeah, I didn't think it was a good question. Okay, so then C.
yeah, this was like the 5 number in the graph.
Yeah, and did I show you that it was interesting when I was watching his video, I showed it was a better way to get the minimum and maximum rather than doing just the okay, so if I were to do a graph
Yeah.
and do a legacy dialog, wait, no, it was the analyze statistics, sorry, analyze descriptive
Yeah.
statistics. And if I wanted to do the frequencies, which is where we did the percentages before, if you go ahead and do the statistics rather than actually just adding in the percentiles, when they want to do like the 5 number, you can basically just go down under the dispersion and you can choose the minimum and maximum and then just click quartiles on the top rather than adding in the 25, the 50, the 75. So if you want the quartiles, you just do the quartiles button, minimum, maximum, and then you have your 5 points there, plus the mean, median, standard variation, or standard deviation and variance. So I thought it was cool. I'm like, oh, okay, there's one more step, but you can still type in a percentage if you need to know
Yeah.
that that's not a quartile. So
It's nice.
anyway,
Makes my life a
I,
little bit easier.
it does. So I did a histogram and I basically cut and pasted it.
Me too.
And he says in a short paragraph, describe the data by at least 5 descriptive statistics. So I figured that was the statistics, like the 5 point on a box plot where you have the minimum, the 25th, the 50th, 75th, and the maximum. So I just kind of said the minimum age of a person buying a second home or investment property is 27. The maximum is 58. 25% or less of people buy second properties at age 38, and 50% or less buy properties at age 49, and 75% of people buy second properties at age 55. I was thinking that's what he was asking.
That's what I did.
Okay. And then DI, we did that. That was the Q2 plot. And the hypothesis. Okay, and I didn't realize I was sorry, go ahead.
I just did equals 47 and then not equal.
Yeah, and then when I asked if it was a one or a two-tailed test, I was trying to understand exactly how that goes, and I guess if it's not equal to, it's a two-tailed test.
And if it is, it's just one.
Yeah. Well, not if it's, okay, if it's equal to, it's null. If it's, I'm trying to think, I'm not sure on the one right now, but I know that if it's greater than or less than, then it's just a one-tailed test. If it's the not equal to, then it is the two-tailed test.
Okay.
I'll have to review on the null hypothesis, which is the only one that's equal to. So compute the test statistic, which is basically the z-score. What formula is to be used? So basically the z is equal to the x bar minus the mean divided by the standard deviation divided by the square root of n. When I was trying to type that, confused, I guess, when I was trying to figure it out, but I watched the video. So the x bar is the mean that we got on the computations. Right, and the other mean was 47. For some reason, I switched them around the first time, but then I fixed it. And it's interesting because it seems like the answers on the video actually went with the answers that I got. But if you're looking at the answers that the book gave, they had it just slightly different on the numbers.
Did you get 0.207?
I got negative 0.209. I think the book showed 0.207. Or this thing did. When I did it and the video showed it, I was feeling better. But yeah, it shows 0.207, negative 0.07. But the one I got was negative 0.209. And I don't know if it's, but he got the same answer on the video that I got, because basically you take the 46.73 divided by 40, or subtract 47, which is divided by the square root of 15. So I'm like, okay, well, that makes me happy. Because I didn't get the 0.207.
I think I put all of the numbers in, so I never rounded it until the end. So that might be the rounding thing, because I just put it in the calculator and I just clicked answer, so the answer popped back up, and I divided it by that.
Yeah, I didn't think that I did any rounding.
Oh, really?
But I'm like, I wrote out the numbers, like the square root of 15 was 3.8729833346. And so I divided the negative 0.27 by that number. So it was what it was, but I'm happy that the video showed it the way I had it, because I'm like, oh no, I gotta watch this video. I didn't get that right. I mean, it's so minuscule on the difference too, right? 0.207 versus 0.209. I knew I was in the ballpark.
Yep.
Sure, I understood that. So,
did you get 0.836?
I got 0.8344 for P.
Okay. So this is kind of confusing because I didn't really know what it was asking.
Okay, so this one, when I was going through the video, it was talking about, you know how in the beginning where we have the not equal to is saying it's two-tailed? Basically means that when you're looking at your applet, you're going to have above and below.
Okay.
So basically you pull up the probability applet.
Because like I looked at the answer, I was like, I don't know even how to get this, because in the question you're not it wasn't like specific, like you need to go above or below or in the middle. And so I
Yeah.
kept clicking around, and then I got the answer, and it had the 2 on the sides and nothing in the middle. And I was like, why didn't it just say that?
Yeah, and that's what they said is when they say is not equal to, that means two-tailed. So that's where you have to remember that when you're trying to do the applet to figure it out.
Okay. All right.
And basically
We'll
I
move on
figured
to
it out. Sorry, I figured it out by doing the probability applet, choosing the outside option and putting in the z of the negative 2.091 and then putting in the positive of 0.2091. And then it would give me on the both ends and give me the answer.
Yeah, because I finally did that, and I was like, oh, makes sense.
Yeah.
Um,
Okay, and then the 6
I did.
of D
Go ahead.
compare the p-value to the level of significance, the alpha level. Do we reject the null hypothesis or fail to reject the null hypothesis? And basically, it just wrote the alpha was 0.05 and the p-test value was 0.83. So if it goes back to the if the p is low, reject the null.
Mm-hmm.
So you fail to reject it because p-value is larger than the alpha.
Yep. So I got.
Okay.
State your
7.
conclusions in terms of the alternative hypothesis. You basically can't see the mean of everyone. I mean, you can see the people in his area, but not the national average.
And when I watch the video, it says that you're going to, when answering this question, you're either going to state that you have insufficient evidence to conclude or sufficient evidence to conclude, and then put their thesis.
So insufficient
Evidence to conclude that 47 years old is not, the average.
for the nation, I guess.
Yeah. And so on the take action, it just says he can continue to advertise to the 47 or less age group of people because it's not been disproven that that's the age.
And target them. All right. I like when those are quick.
I liked the video because I was like, okay, I just want to make sure I'm doing this right.
Mm-hmm.
So then are we supposed to, I guess we're going to do our group meeting quiz.
I guess so.
Let me go get that open. And then I'm going to go back and do the 8 quiz later today because I need to get that done. But
And I think I might take the test today.
I'm hoping, but I want to get an answer first.
That's true. Maybe I'll wait for the answer. He'll probably get it to us before late.
Yeah,
He's
let me get.
usually pretty good about getting them answered.
I think as a teacher, he really does care about trying to help his students.
Mm-hmm.
I mean, I feel like he's gone above and beyond in a lot of cases.
Mm-hmm.
Meeting quiz.
Oh, we got 21 questions.
Let's see if we can get these. Get the quiz. That's easy. 2 is easy. Which hypothesis involves equality, which is equal, and that is the null hypothesis, because that's the only one that is equal.
Mm-hmm.
I would say.
The p-value is a probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use this information to answer the next question. Remember that the p-value is the probability of obtaining a sample statistic at least extreme as one that is actually observed. When computing the p-value, which hypothesis do you assume to be true?
Is that the null hypothesis? Let me see.
I think so.
I'm pretty sure it is, but let me find the verification of it. Okay. We assume that the null hypothesis, we assume that the null hypothesis is true. This is with the p-value though, right?
Yeah.
I know it's somewhere in the reading because I think I read it.
Yeah, I'm looking through the reading right now. So it says p-value is the probability of getting a test statistic. I can't talk. The p-value is the probability of getting a test statistic at least as extreme as the one you got, assuming HO is true.
Assuming the null hypothesis is true. Yes, I just barely found that one. So that would be the null hypothesis. Which is what I thought, but it's nice to have it verified.
Yeah. Okay, suppose the null hypothesis is HO, mean equals 10. Use this information to answer 3 questions. Which of
Yeah,
the following represents the alternative for a two-tailed test?
I think it's the 3 because the two-tailed means the not equal to, right?
I think so. I think that's what our, at least what we just did. It looked like that.
Mm-hmm. That's what I'm pretty confident in that one.
The n equal?
That is not equal to. Yeah, the HA of the mu is not equal to 10 because it says the two-tailed test. And I'm pretty sure that they said that was the only two-tailed test in the video, in the stuff that I watched. And then the
Which
left-tailed test. That means less than because it's left-tailed. So the mu is less than 10, which is what I would say A, or the first option.
And then right tail is B.
Right-tailed is greater than, so that's B, yeah.
Remember that we determine the outcome of a hypothesis test by comparing the p-value to the level of significance for alpha. Next 2 questions. Which relationship would result in failing to reject the null hypothesis?
If it's low, reject the null, right? If p-value is low, reject the null is what they said. So p-value is greater than alpha? Because didn't we say in the thing if the p-value, yeah. So if we do, but because if it's low, we reject it. But if we're failing to reject it, then it means it's larger than the null or than the alpha. So I put A. The first one, p-value is greater than alpha.
And then rejecting the null is the opposite.
P-value is less than alpha.
Okay. It's not too bad so far. An insurance company is reviewing its current policy rates. When originally setting the rates, they believe that the average claim is around 1,500. They are concerned that the true mean is actually higher than this. Which of the following would be the appropriate alternative hypothesis for HA?
They're worried that the claim is going to be greater than it, right? They're concerned that the true mean is actually higher than this.
HA is the alternative.
So I put 3 for number 10.
You did 3?
Yeah, I did, just because it says the claim amount is greater than 1,500, because when you look at the wording, it says that they are concerned that the true mean is actually higher than this. So they're thinking that the claim amount, the average, is going to be higher than the 1,500, what they suspected. So the higher is where I would say, you know, greater than 1,500. And that's for number 10.
Although it's the alternative.
Wait, okay. Sorry, which number we're on? Oh,
Oh,
yeah,
we're
that's
on,
not
I was
the,
just
hypothesis. It's greater, the claim is greater than 1,500. I don't know. Of the alternative hypothesis was that the mean is 1,500. The alternative hypothesis be that than 1,500.
all right. We're good for 11.
Yeah, so on number 11, which of the following would be the appropriate null hypothesis would be that it is equal to 1,500.
Okay. Okay. I just saw a little chart that made more sense. Okay. Number 12.
Okay.
What are we looking at?
The insurance company randomly selects n equals 40 claims and calculates a sample mean of X bar is 1650 to answer the next 3 questions. The insurance company assumes the distribution of the sample mean is normal. Is this a good assumption? 40. Um, mm, And I know when I looked at the video, it seems like he said that this was, yes, it is a good, since the population is normal, but does that say anything that the population is normal? Are we still referring? No, that's all the information it gives us is that the insurance company randomly selects. And oh, it's normal because n is equal to, like when we say n is 30, if it's above 30, then
Yeah.
it would normalize out regardless, right? Because they had enough population. So yes, it is a good assumption since the population is normal. Wait, okay, is a good assumption since the sample size is large, maybe.
I think it might be sample size. Because isn't n sample size?
Yeah. Yes, it is. So it's a good assumption since the sample size is large, is what I would guess.
I think so. And then what theorem or law justifies our answer from the previous question?
Central limit theorem.
The law of large numbers is isn't central limit theorem like when it's distributed?
Let's see. The central limit theorem is that the distribution will have a normal distribution if the sample size we choose is large enough. That means the
And the
sample
log.
mean will be approximately normally distributed, so it is the central limit theorem. Yeah, in the law of large numbers, the sample mean draws closer to the population mean, but on the central limit theorem, it's talking about how it will have a normal distribution if the sample size is large enough. So central limit theorem.
50, and then 14, which of the following is a test statistic as defined in this lesson? And that is Z.
That's the Z, yeah.
The historical means of sales receipts at a grocery store is 150 with a standard deviation of $40. The store manager suspects that the average has decreased. She sets up a hypothesis test with these hypotheses. She will use a level of significance A equals 0.05. She then takes a simple random sample of 36 sales receipts from her store and computes X bar equals $144. Okay, so what is the Z-score associated?
Yeah, we're gonna need to pull up the Excel sheet maybe. Trying to think. Let's see, because it's got the store managers. Okay, so you've got, sorry, let me get this information. Okay, yeah, standard deviation and the mean. So the mean is 150. The standard deviation is 40. She'll use a level of significance of 0.05 and her X score is, and it didn't say, okay, she does have a sample of 36 sales, so that's 36, right?
Yep.
So I got the Z-score as a negative 0.900.
Yeah, that's what I got. It was like 89999.
Okay. Yeah, if you use the Excel sheet that he had with the formulas, it automatically rounds to that decimal.
I know, that's nice. I know how to do it faster just
Yeah.
because, I don't know, I like writing things down. But then I just sometimes struggle with rounding, especially if they're like the entire numbers are getting different. So you got negative 0.900.
Yeah.
What
And
is
the
the
p-value, he says you do the Z-score into the applet, so we're supposed to pull up the applet.
And what is it looking for?
And it's looking
associated
for,
with it?
sorry, let me see. So we're looking at, in the question, it's saying that she thinks it's going to be less than, right? The very first paragraph, it says she suspects the average has decreased, so it's going to probably be on the applet and be below.
Okay, I got 0.184.
So below the negative 0.900. And I got the 0.184. 0.184, I got positive because basically I went into the applet and the mean is 0, standard deviation is 1. I clicked the below button and I typed in the Z-score of negative 0.900, and that gave me the probability, which is 0.184.
What inference would you make about the null hypothesis for this problem? So,
Well, you're looking at the p-value. What would you make?
fail.
Do you reject it or not? If the p-value
that?
is low, reject the null, right?
Mm-hmm.
So which one are we on? 17. So if the p-value, what was the alpha value?
Oh, it just said
They
that.
said the alpha value
It was
was
0.05.
0.05. So our p-value is larger than 0.05.
So
So
it just
it's going to
reject the
be
null.
fail to reject it.
That's what I thought.
What is your conclusion? We have insufficient evidence. Let's see. Insufficient evidence that the population mean is 150. We have insufficient evidence that the true population is less than that. Wait, no. Fail to reject it is what we said, right?
Your conclusion
Okay, sorry, I'm
is
looking at
A
it.
or
Fail to
C.
reject. Okay. And I know we failed to reject it. So that means that we have insufficient evidence
Is it less?
that the mean is less than 150 because that's what she was trying to say. Well,
Yeah, because she said it's decreased.
yeah. So we have insufficient evidence that the population mean is less than 150 is what I would say.
Yeah.
Okay, and
There are
question
two types of
19, what
Go ahead.
type of errors can be made when performing a hypothesis? Rejecting the null hypothesis when it is true. Is that type 1?
Type 1.
Rejecting the hypothesis when the null hypothesis is true. It says if you fail to reject, then the correct decision is type 1. Type 2 would be the, okay. So I think it's type 1. I need to memorize those things.
Whenever we reject a true null hypothesis, we say that a type 1 error is committed.
And where was that one?
That is in 4.5.
Okay, I just am on that page. Okay, whenever we reject a true null hypothesis, we say it's a type 1 error was committed. But we've, okay. Because we failed to reject it, right? So the type 1 error says whenever we reject it, one error. I'm so confused on this. I know that I have the answer as fail to reject and type 1 error, but and I know when he went over it, he's like, this just, you have to memorize this, which is, type 1 error means that rejecting the null hypothesis is when the null hypothesis is true.
So which one involves, so I guess this doesn't even matter with the rest of the questions that we've answered. It just says there are two types of errors that we can make. So which one involves rejecting the null when it's true? And so in it just says whenever we reject a true null hypothesis, we can say it's 1.
Okay, so that is a
And
type 1 error. Okay.
yeah, I mean, although we had different answers from the work we did, it doesn't like,
It
I think
doesn't
it
tie
says, yeah.
in. Okay, yeah, that makes more sense. I'm like, wait. And that's just, okay.
Instead of using a level of significance of 0.05, he will use 0.01. Which of the following is true? So whenever 1 goes down,
They had something specifically on there about, let's see. of significance of, okay. If we choose the alpha to be so small, we rarely commit a type 1 error. And it's lessening it, right? So we rarely commit a type 1 error. So if they're asking which of the following will be true, the type 1 error will
decrease.
increase.
So it says probability that the null hypothesis is true will decrease. That's the only one that says anything about getting smaller.
Yeah, and I think it's going to be that the type 1 error will increase because if you read in the book, it says the alpha to be so small that we rarely commit a type 1 error. So it means if you lessen it, you lessen your likelihood of making a type 1 error.
Mm-hmm.
Okay, so type 1 lessen. Which of the following will be true? A researcher decided instead of using a level of significance of that, so he decreased it, of a type 2 will increase because the probability of type decrease with the decrease of that number. So that's opposite side. It means type 2 will increase. So I say B, or the second one. And that's
What
saying,
did you say?
I put B because if you look on
Yeah.
4.5 where you were looking just a moment ago,
Mm-hmm.
if you go down to the paragraph that's underneath the talks about the decision, fail to reject or reject, that first paragraph, if you look at the second sentence, it says if we choose alpha to be so small that we rarely commit a type 1 error. Decreasing that makes it less and less likely that you will make a type 1 error. And on the flip side of that, makes it more and more likely that you will make a type 2 error. So 2 error will increase. And then question 21. If alpha is 0.05, compute the probability of committing a type 1 error. And he says that that's the definition of it. Alpha is a type 1 error. And I think I've seen it somewhere. Yeah. There's something in here. Yeah, if you look in the next paragraph of where we were just reading, it says if the alpha value is very small, the probability of committing a 2 will be large. Type 1, however. Yeah, when he was going through it, he said that that the definition is that it would be a 0.05 because the alpha is a type 1 error. So that would be the probability of, because that's what it's measuring as a type 1 error.
Oh, because we move it. Oh.
So
Right?
he said it was part of the definition of the alpha because the alpha is what you're computing to make sure you're not creating errors. But as part of the definition is the alpha they're giving it to you is 0.05. So that is the probability of committing a type 1 error. That's how measure alpha measures. Let me see if I can find the page. He's like, they give it to you.
Okay.
Okay. Let me see. I know there's somewhere that I don't know if it was just in his video that he was talking about it, or if there's a place in the book that I read it, but it's just kind of part of the definition. That's one thing you need to know is that the alpha is basically the probability of committing a type 1 error.
So when we did the preparation assignment, it says if the analysis was done at A equals 0.01 level, what is the probability of committing a type 1 error? And we did 1%.
Mm-hmm.
So
That's
would that
true.
be the same? Just 5?
Yeah, well, yeah, but you're going to still do it in the 0.05.
Decimal places.
You're just going to leave it the way that it is there because you were changing it to a percent. They're wanting a decimal. You were just, on that question, you were just basically saying what the data meant. Like putting it in more familiar terms, that's what it means as a 1% chance. This one, it just wants what alpha is, which is point.
Okay.
And like I said, you can watch the video too, but I think that's how he described it. And so that's just what it means, and that's what you just have to know. I'm like, okay, good to know.
Well, I'll submit it. $100. We did it.
Yep, 100%.
Okay, neat.
Okay.
Wasn't horrible.
Did you want to try to do the group homework quiz, or do you want to do that on your own? We haven't done it before. I just wasn't sure. I know that he went over it in the video.
Yeah. I might just leave it for later. I don't know.
Okay, that's fine. I'm going to go ahead and